So you've built a machine learning model, and it's hitting 99% accuracy. That's a huge win, right? But what if you can't explain why it made a critical decision? A decision that really impacts a user? Well, that's where accuracy just isn't enough. In this explainer, we're going to crack open that black box and get into a skill that's absolutely essential for every developer today: explainable AI. So here's our game plan. First, we'll dig into the black box problem, something I'm sure you've run into. Then, we'll introduce explainable AI as the key to unlocking it. After that, we'll go on a tour of some really practical techniques you can start using right away, see how they fit into your day-to-day development lifecycle, and finally, we'll talk about why knowing this stuff really gives you a major edge. All right, first up, let's talk about a challenge that's just getting bigger and bigger as our models get more and more complex. I'm talking about the black box dilemma. Okay, so picture this. You've built a beautiful deep learning model, kind of like the one you see here. The accuracy metrics look amazing, but then a stakeholder or a user asks you, hey, how did it make that specific prediction? Can you really trace the logic back through all those hidden layers? Yeah, that's where things start to get a little fuzzy. And, the reason it's so hard is because that decision-making process is smeared across maybe millions of different parameters in those hidden layers. The model becomes, opaque. It becomes a black box. And that lack of transparency isn't just some technical curiosity. It's a massive business risk. So obviously, we need a way to open this thing up. We've got to find a way to go from this opaque, almost untrustworthy process to one that's transparent and, actually explainable. And that's exactly where explainable AI, or XAI, comes into play. You can think of it as a whole collection of methods and processes that let us, as humans, actually understand and, this is key, trust the outputs of our models. It's really about having a solid answer when someone asks, so how did the AI figure that out? And let's be really clear about what's at stake here. This is not just some theoretical academic problem. Models that are black boxes can lead to outputs you just can't trust, and that can cause real-world harm, damage your company's reputation, and it can kill your project. Okay, so enough with the theory. How do we actually put this stuff into practice? Let's take a look at some seriously powerful XAI techniques that you can start plugging into your projects, like today. Let's start with a really simple, very human question. When a user gets some automated decision they don't like, what's the first thing they think? It's almost always, well, what if things were different? This is where counterfactual explanations are just brilliant. They answer that what-if question directly. So for instance, instead of just flatly telling a user, sorry, your loan was denied, you can give them actionable feedback. Something like, if your income was just $5,000 higher, your loan would have been approved. See how that completely transforms a negative experience into something constructive? It's a game changer. Okay, let's switch gears a bit. That was about the end user. What about for us, the developers? When you're trying to debug a model, especially something complex like a computer vision system, you really need to know what is this thing actually looking at to make its decisions. Feature visualization is a technique that helps us answer exactly that. It can literally highlight the pixels in an image that were most important for a specific prediction. Now, think about a high-stakes field like medical imaging. This is absolutely invaluable. You can use it to make sure your model is actually identifying clinical markers, like a tumor, and not just focusing on some random watermark from a hospital that happens to treat a certain group of people. It's an incredibly powerful tool for sniffing out and fixing bias. So the big takeaway here is that there's no single magic bullet for XAI. You really need a whole toolkit. This table sums things up nicely. You've got counterfactuals, which are awesome for user feedback. Feature visualization is your go-to for debugging and bias detection. Then there are things like influential instances, which can help you find bad data in your training set. And deletion diagnostics can tell you if your model is leaning too heavily on just one feature. So you've got these cool tools, but the question is, when and where do you actually use them? The most important thing to remember here is that explainability can't be an afterthought. You can't just bolt it on at the end. It has to be baked into your development lifecycle right from the very beginning. This should look pretty familiar to all of you. It's a typical AI development lifecycle. The crucial point I want to make is that explainability isn't just some final step you check off before you deploy. It's a mindset, a practice that you have to weave through multiple phases of this entire process. Let's get really specific about where this matters most. During the build phase, you're using XAI to understand your model's guts, its internal logic. Then, during the test phase, you use these techniques to really hammer on it, checking for bias and fairness. And it doesn't stop there. In the monitor phase, after deployment,
You use it to understand how your model is behaving in the wild and to catch any of those nasty, unintended consequences.
Okay, let's wrap this up by focusing on what really matters. Why should you, as a developer, invest your time and energy into mastering all these XAI techniques? What's the bottom line? So what is the payoff? Well, it's huge. First, you're going to build products that people actually trust, and that is priceless. Second, you'll become a much more effective developer because you can debug your models way faster. Third, you'll be building more ethical and fair AI, which is just a massive responsibility for all of us. And finally, you're going to be way ahead of the curve on regulations like the EU's AI Act, which are making this stuff a legal requirement. So as you start thinking about your next project, this is the one question I want you to ask yourself. Are you building a model that's explainable by design, or are you building a risk that's just waiting to happen? Because in today's world, building explainability into your models isn't just good practice, it's really the only way to build AI that's robust, responsible, and ultimately successful.